Hello, it's Alex from Zama. I'm a software engineer in the Concrete compiler team, and today it's my great pleasure to introduce you to a new feature, Concrete for Rust. Until today, Concrete only had a single frontend. It was Concrete Python. Python is a great programming language. It has a huge ecosystem of libraries, and its flexibility makes it very good to prototype new applications. That being said, when it comes to deploying these applications in production, it may be better to use a stricter programming language. At Zama, we have been fond of Rust since day one. Its memory safety feature makes it very good to implement low-level cryptographic primitives. Rust is also very good to implement robust applications. With this new feature, we try to give you the best of both worlds. You will be able to prototype your model from Python using all the tools from Concrete Python. And once you are done, you will be able to import this model inside of your Rust application as you would do for any dependency. Let's see how to use that. So here is a small module from Concrete Python. Essentially, it's just a class that is annotated with this FHE.module decorator. Inside of this class, we find as many static methods as we need, all decorated with this FHE.function annotation. In our case, the module is a fairly simple one. It's a counter, modulo 20, that has an increment and a decrement method. We can compile our module using this compile method. And once we are done compiling, we can save it to a zip file using the save method here. And essentially, this is all there is to using this feature for Concrete Python. Now let's see how to use that from Rust. In Rust, your entry point to this feature is going to be this macro from the Concrete macro crate. You can see that it expects a path to a zip file exported from Concrete Python. But what we can see is that under the hood, this macro embeds the whole Concrete compiler. During the expansion of the macro, all the necessary binary artifacts are going to be regenerated by Concrete compiler. Once this is done, Rust is going to embed this binary dependency inside of your Rust application as it would do for any classic Rust dependency. What this means is that there is zero overhead to using this feature during the execution. Essentially, everything is integrated within your Rust application. It's also very nice because you don't have to manage all the artifacts during the execution. All that happens at compile time, and it's directly integrated inside of the Rust binary. The last good thing with this approach is that on top of this low-level integration, we automatically generate a user interface that mimics the API of the original Concrete Python module. That makes it very natural to use this feature from within Rust. As you can see, I have access to all the compilation from my IDE, and the language server essentially has access to all the signatures and everything. Yeah, it feels very natural. Now, how to use this export from within Rust. So here is a small example. We begin by generating the CSPRNGs. We generate a key set, and then we are going to try to call the decrement function on a value. To do that, we instantiate a client object for the dec function, and we also generate a server object for the dec function. We generate a new value that we will use as input, and which contains the numeric value 5. And using the client object, we prepare it, which means we encode it and encrypting using our key set. Once this is done, we send it to the server, and we use the invoke method on the server object to actually execute the FHE computation. We gather our output and send it back to the client, where we process this output, which means we actually decrypt the value. And we print it. So let's see how it goes when we run it. Okay, the execution is over, and we can see that the output that we got is 4, which is essentially our input 5 decremented by 1, which is what we expected. So yeah, that's it for this new concrete trust feature. We really hope that you are going to like this new feature, and we are really looking forward to having your opinions on that and how to enhance this new feature. See you!